Hi, welcome to the video on optical remote sensing systems. In this video, we will answer the questions, what are optical remote sensing systems? And we start with two types of remote sensing sensors. The first type are so-called passive sensors. They require an environmental radiation source or an environmental source for your transport medium in general, like solar radiation, like terrestrial radiation, or like environmental noise. And that environmental information carrier medium is then recorded from your sensor. The other type are active sensors. They bring their own source for the information carrier medium. And you all know the radar systems. Microwaves are emitted and they are scattered back from some objects in the atmosphere, for example, from airplanes. And that's detected by the radar system, so it has its own source for that information carrier, and it's also there generally electromagnetic radiation, but you can also use sound, so you can use a loudspeaker and then detect the reflected noise with these active sensors. When we talk of optical remote sensing systems, then we always talk of passive sensors. So they require an environmental radiation source, and it's always electromagnetic radiation, which is generally associated with this term. And to be more precise, the electromagnetic radiation is restricted to a certain wavelength. And that wavelength starts here in the ultraviolet spectrum, so around 0.2, 0.3 micrometers, and then it reaches up to 13 to 15 micrometers. The graphic here also shows the atmospheric opacity. If it's 100% here, that means radiation coming from the sun and reaching the Earth won't penetrate through the atmosphere. And opacity around here, so in a lower percentage degree, means radiation from the sun actually passes through the atmosphere and reaches the surface. And you see in that range where we have these optical remote sensor systems operating, there are quite a few such areas where the radiation can penetrate through the atmosphere. These are so-called atmospheric windows. But there are also small regions where the radiation can't hardly pass the atmosphere, which are called absorption bands. And that's the range where we're talking about when we talk about optical remote sensing systems. One look on these two radiation sources which are behind that range. It's the sun and it's the Earth itself. And both objects emit radiation. The emitted radiation depends on the temperature. And as you can see here, and have a look on the logarithmic scale on the y-axis, the sun emits much more radiation than the Earth, and much more radiation is actually coming from the sun to the outer Earth region than we emit into space. And when we look at this graph, we see two things. The first thing is that the area under that blue curve is much smaller than the area under this red curve. And that's the so-called Stefan-Boltzmann law, and you see that it's a quite exponential function actually to the power of 4, and it depends on the temperature of the body which irradiates that radiation. And since the sun has around 6,000 Kelvin, it's much more radiation emitted from the sun than from the Earth, which has around 280, 290 Kelvin surface temperature. And the other thing you see in that image is that this peak here, where the maximum radiation is emitted, and on the x-axis it's actually the wavelength. And for the terrestrial radiation, it's around 10 micrometers where we have that peak. For the solar radiation here, it's around 0.5 micrometers. So obviously, the warmer a body is, which emits that radiation, the shorter is the wavelength where we have that peak. And that's called Wiens Law. And you see that inverse relationship here in that equation, that it's inversely related, this lambda max here, so the wavelengths where this energy is emitted, or the maximum energy is emitted, is inversely related to the temperature. So for the sun, around 0.5 micrometers, that's the region where the maximum radiation is emitted, and that's somewhere in the green spectrum of the visible light, where we get this energy income. See you next time.